In this video, we want to know the mole relationship for ideal gas. In order to know the mole relationship for ideal gas, you need to know the formula for ideal gas. Now, what's the formula for ideal gas? The formula for ideal gas is PV is equals to nRT. Now, what is P? P represents the pressure, and the pressure is measured in millimeter mercury. Sorry, the pressure is measured in ATM. Although, if the pressure is given to you in millimeter mercury, you have to convert it to ATM. Now, we have the V, which is the volume, and the volume is measured in dm³. Then we have the N, which is the number of mole. Of course, is measured in mole. And then we have the R. The R is the general gas constant, general ideal gas constant. All right, general ideal gas constant. General ideal gas constant is about 0. My pen is fading. About 0.0821. Okay, and it has a unit. The unit is ATM. All right, the unit is ATM multiplied by dm³ divided by mole per Kelvin. So this is the unit. All right, just one over here. All right, so now this is the unit for the general ideal gas constant. In case you don't know how we got the unit, let's do it for you on the board here. Now we know that the general ideal gas constant is R. So we have that PV is equals to nRT. So we're making R the subject of the formula. We're dividing by NT. We're dividing by NT. So that R is equals to PV/NT. Please, what's the unit for the P? That's the pressure. I told you it should be measured in ATM, not millimeter mercury. If it's given to you in millimeter mercury, convert to ATM. So I have ATM. What's the volume? The volume is in dm³. dm³. That's dm³ like this. Now, what's the number of mole? Number of mole is mole. Amount of mole is mole. What's the temperature? The temperature is Kelvin. If you do your math, you're going to be having 1 ATM times by dm³ divide by mole and Kelvin. So that's the unit there. Then what do we have there? Last one is temperature. This is known as the absolute temperature. And then is measured in Kelvin. All right, these are what you need to know while calculating for mole in ideal gas. And let's say we have a question. Question number 1. Calculate the amount of mole in the following. Calculate the amount of mole in the following. Question number 1 or question number A. 300 cm³ of ideal gas exerting a pressure or exerting the pressure of 600 millimeter mercury at 40 degree. Now question number 2, 150 cm³ of ideal gas exerting the pressure of 400 millimeter mercury at 60 degrees Celsius. So we have a question. Let's start off with the first one. How do we solve the first one? So I need to, let's use this side of the board. Okay. And I hope you have written all this down. So let's clean up the board. Let's clean up the board. And leave the constant there. Leave it there. All right. Now, what we're going to be having now is, number one, we need to convert 50 cm3 to dm3. How do we do that? 1000 cm3 is equals to 1 dm3. So I'm going to be having we're starting with 300 cm3. 300 cm3 divided by 1 times by 1000 cm3 gives me 1 dm3. I'm going to do it in such a way that cm3 will cancel cm3 using my conversion factor fraction, knowing that 1000 cm3 is equals to 1 dm3. 1 dm3 is equals to 1000 cm3. So doing that, I'm going to be having my calculator to be, okay, let's calculate now. It will be 300 divided by, because 300 times 1 is 300, 1000. So that will give me 0.3. So the answer here is 0.3. We're going to circle out our answer. Just keep it aside. So we're looking for pressure. The pressure is 600 millimeter mercury. We need to convert it to ATM. All right. Understand that 1 ATM under standard condition will give you 760 millimeter mercury. So I'm giving 600 millimeter mercury. 600 millimeter mercury. All right. I'm using my conversion factor fraction. I'm going to put 760 millimeter mercury at the bottom so that millimeter mercury will cancel out millimeter mercury, and I have 1 ATM at the top. So that when I do that, this will cancel out, and then I'm going to have my answer. I'll be having 600 divided by 760. I'm going to be having 0.789. 0.789. 0.789. Okay, let's keep that down. Is there any other thing to convert? Yeah, 0.789. All right, should we put the units? Of course, this is dm3. And then this is what? ATM. All right, from here we are converting from cm3 to dm3. Here we are converting from millimeter mercury to ATM. All right, so please take note of that. Now we're going to the next one. The next one is to convert, the temperature is in Celsius. We need to convert from Celsius to Kelvin. So I have 40 plus 273. All right, that should give me 303 or something. So we have 40 plus 273. That will give me 313. So I have 313 Kelvin. Now, let's bring in the formula that we are going to use. Now, this have been converted, this have been converted, this have been converted. The formula remains PV is equals to nRT. Now, we're looking for N, which is the number of mole. So the N there is divided by RT, divided by RT. So what do we have? Make a space for myself. I need this value. All right. So that N is equals to, these guys will die. So PV is equals to RT. Now, what is your P over there? Look for it. P. Okay, pressure 0.789. Now, what is your V? V is 0.3. All right, I'm dividing it by, what's the R? The R is here. 0.0821. And then we're going to multiply by, what's your T? Your T is 313. All right, let's do that in our calculator. So we have 0 0.789, 0.789, okay? And then we have 0.3, all right? Then we're dividing it by 0.0821. Sorry for that. Let's start again. Press the wrong thing. All right, 0.789, okay, multiply by 0.3, and then we're going to be dividing it by, come on, move now. All right, 0.0821. Then we're multiplying by 313. All right, the answer is 0.009211. 0.009211. 0.009211 mole. So that's our final answer. Well, the next question, we're going to leave it for you. Use the same pattern and then solve. You will get the answer. You can pause the video and try out the question. Anyway, let's solve. Now we will go back to conversion process. And what's the conversion process? At this time, we are not going to be waiting for you. Just give us the formula. PV is equals to nRT. We won't wait for you now. And then we know that N is equals to divided by RT, divided by RT. N is equals to PV over RT. So let's start up now. Let's do our conversion factor from here. Now, we are having 150 cm3. Let's start with converting 60 millimeter mercury, because that's the pressure. Well, let me help you anyway. So we're converting from millimeter mercury to ATM. Now, we have, what is given to me there? 400 millimeter mercury over 1 times by 760 millimeter mercury. Do it in such a millimeter mercury, we cancel millimeter mercury, gives me 1 ATM. I get my answer here. Then for DMQ, I'm giving 150 cm3. I'm trying to convert from cm3 now to DMQ. All right, so I have 150 cm3. Use my conversion factor fraction. I put 1000 cm3 at the bottom. I put 1 DMQ over here. So the next one is I'll convert Celsius to Kelvin. So what I have is 60 plus 273. So let's get our values. Then we now have that R is equals to PV over RT. So we slot in what we have. Okay. Now, let's start up with this. This is 400 divided by 760. Okay, 400 divided by 760. That will give me 0.526. So I have 0.526 ATM. All right, 0.526 ATM. All right, the next one is 150 divided by 1000, 0.15. So that will give me 0.15 DMQ. All right, of course, to convert to Kelvin, 60 plus 273. That will give me 333 Kelvin, 333 Kelvin. I have 333 Kelvin. Let's note what we have. The pressure is now becoming 0.526, the new pressure. And then the volume is 0.15. And then the constant here is 0.0821. Don't forget that. And then what do we have again? From the formula T, which is 313. All right, let's slot in what we have. Find the answer. So we have that value, 0.526. Then we're multiplying by 0.15. And then we're going to be having 0.021. I'll press the wrong thing. 0.821. And then we have 313. So The answer is 0.003. Yeah, 0.003. So I have 0.003 mole. This is, oh yeah, mole. Now that's the final answer. This is all we've got for you. Have a great day.